Okay, hello everyone. For part two, we're just going to go quickly over research methods, which is the second chapter of your book. And so, first I want to ask, well, why do I need to know research methods? Some of you out there might be thinking, oh, well, for what reason do I need to know this? Um, I told you in the first module, and I'm going to keep reminding you, psychology is a science, and any kind of science needs to have research. There needs to be some valid arguments behind your theories. It just can't be ideas and what you think things are, or hypotheses. So, this is why we need to know research methods. So, requirements for psychological research are that research needs to be objectionable. It needs to be objectionable observation. It means that it needs to be based on facts, and they should not have any bias. So we're going to be talking a lot throughout the course about bias and how bias plays a lot of roles and is very problematic. Shouldn't be things based on a hunch or a guess. There are always, with any kind of research or experiment, there needs to be a control group. So there needs to be, going back to the lighting example, if I'm going to say that having good lighting is important for productivity, I need to show that there's a group that doesn't have good lighting and their productivity is not so great. So you must be able to control different factors. And it must be able to be they must be able to have duplication and be verified, which, like I said before, if you're saying that this is indeed a fact, it needs to be a fact for people in California, it needs to be a fact for people in Florida, it needs to be a fact for people in Virginia, it needs to be a fact for people in Maine. So research does have its limitations, and you can't do a research experiment for everything. Not all behavior can be studied. There are currently a lot more restrictions on what you can and cannot do. And observing behavior, as we learned with the Hawthorne effect, changes. So once people know that they're being watched and they're being studied, people automatically change their behavior. Also, most experiments are done in artificial settings. Very few experiments can be done within actual workplaces. And most experiments use college students as subjects. And although college students are awesome and amazing, and they are not always a great sample of the general population. There's all kinds of different people out there. So if you're only studying college students, it doesn't make it verifiable to everybody. So you can't say something is a fact if you've only researched it amongst college students. There are 4 different kinds of research methods. There are experiments, there's observations, there's polls, there's surveys, and there's web-based research. I'm just going to talk about experiments today. In your book, you can find information on the other 3. So for there to be a research experiment, you need to have an independent variable and a dependent variable. I kind of think of it as the independent variable is, if I do this independent variable, you will behave like this dependent variable. So independent variable is the thing that I'm doing, and dependent variable is the thing that I'm looking at, the thing that I'm observing in you. Once again, you must have a control group and you must have an experimental group. The control group is the group of people that you're going to leave alone. You're going to let them do whatever they're normally doing, and the experimental group is the group that you're going to make the change on. Groups help to be random or matched. So either you pick people randomly, or you pick a certain group of people and you try to make the groups as similar as possible. There's some problems with experiments. Sometimes it's hard to isolate what is going to be the independent variable and what is going to be the dependent variable. Sometimes you can't get a good control group. Once again, it's always in an artificial environment, most always. Sometimes you can do things in their natural environment, but generally it's going to be something artificial. And there's the ethics problems. You can't do things to people anymore. You could do them in the 50s. You can't do things to people anymore that will cause them harm or upset. Take, for example, the Milgram experiment. I don't know how many of you out there have heard of the Milgram experiment, but really quickly, this is an experiment where people were asked to shock other people. They weren't shocking real people. It was make-believe. It was kind of imagined. And people were asked to go in and, press a button where they believed that they were hurting other people. And the idea of the experiment was to see if people, just by simply asking them, had the ability to hurt other people. It came out of World War II. And the answer to the experiment is yes, they do. But unfortunately, a lot of people left that experiment feeling really not so great because they now know that they have the capacity of hurting others. So the Milgram experiment it's kind of no dice anymore. We don't do that because it violates ethics. Although I did read an article that it might be happening somewhere in Europe, but at least here in the U.S., we can't do those things anymore. Real quick, we can look at measures. So when you do an experiment, you get a lot of data, and your data generally looks something like this or something like this. When you plot your data, it kind of looks like some kind of a bell curve. And so when you have your data plotted out, you're looking for three things. You're looking for the mean, the median, and the mode. And like I said, for most of you, this is probably review. But the mean is the average. The median is the number exactly in the middle. And the mode is the number that appears most often. So in a standard deviation, which is what this is here, the mean, the median, and the mode are all equal. Okay? That's all the same number. Let's say if this number at this point was 1, this number at this point was 2, this number was 3, this was 4, and this was 5. 3 would be the answer to both the mean, the median, not the mode, because actually 3 doesn't appear more than once, but if it did, that's where it would be. However, so that's a standard normal distribution. Most of your distributions won't look like this one. They'll actually look like this one on the bottom, or something very different. In a skewed distribution, the mode is actually higher than the mean because that number appears most often, but actually this number is the average. Okay. So just important. Why is this important? Because, well, as we are looking at research results, we want to know what they mean. So, if I get on this one, if I get a 3, I want to know, am I average? Am I with everybody else? Or, if I get a 1, does everybody else get a 1? So it lets you know where you're at. And to even better let you know where you're at is the standard deviation. And that is the precise distance from the average or from the baseline to let you know how far you are. So all this to say is when research scientists are doing research, they're looking for these things. What is the average? What do most people get? And is that average significant? If you scored a 1, you are an outlier. Where if you scored a 3, you were with the average population. So we want to know what things mean. Okay? So one more thing about statistics. Inferential statistics, it's a method for analyzing data and expressing relationships and difference between groups. What researchers are looking for is statistical significance. So when we're saying that these things are a science, and when we're talking about these theories, they have statistical significance. That means we're pretty confident that the results of the experiment are highly valuable, and they're based on good probability values. What's probability? Well, probability is the idea that the difference between the means of the experimental group and the control group could not have could have occurred by chance. So but when we have that control group and we have that experimental group, we want to make sure that the experiment was right. So let's go back to our light bulb experiment. We changed the light bulb, productivity went up. Well, we want to make sure that everyone could have had a good day. We want to make sure that it's actually because of the light bulb and not because of something else, or something that could have happened by chance. And so that's when we go in, and there's a whole statistical equation for figuring out probability. But I just want you to know that this is what we're looking for, and this is how we validate this as a science. Okay. All right. Well, that's it for Module 2. Can't wait to see your involvement in discussions, and look forward to seeing more of you. All right. Thanks.